Good afternoon. I know everybody must be really tired and sleepy. I know that we back for too long. So without further ado, let's begin today's final panel. And the topic is scaling Ethereum and beyond. First of all, let's introduce ourselves.
Hello everyone. So Anthurine, I'm the co-founder for eStorage and QuarkChain. Basically jumping into this area ever since 2018. Always doing like infra. So we are starting from the sharding layer 1 and then pivot into the layer 2. And then plus helping Ethereum to scale on both L1 and L2. eStorage is also like a storage layer within the Ethereum ecosystem. So we are pretty active for the whole Ethereum ecosystem.
Hello, this is Zheng from Her2 protocol. Her2 protocol is aiming to build an intersubjective consensus layer on top of Ethereum or independent. We newly launched our mainnet, and I also have a background with infra since 2016. QuarkChain has always been a good friend. Yes. So I'm happy to sit here and discuss about the scaling and also on Ethereum. Thank you.
Hi everyone, my name is Mosh. I lead the ecosystem for Boundless Networks. We are the universal ZK hub for all ZK proofs, which means that our goal is really to build ZK technology to service the internet at scale. Previously, I was leading partnerships at RISC-0, which is very much one of the core primitives that Boundless is built on. We were the first team to kind of build the RISC-V ZKVM, which is right now the leading architecture for ZK systems. And then before that, I've been in the space since 2016, also working in infrastructure and primarily at L1. So very excited to discuss all of the challenges of scaling ETH and going beyond.
My name is Charles Cooper. I'm the lead developer for the Viper language. Viper is a smart contract language for the EVM, which optimizes for maintainability, security, and readability. And I've been kind of leading the language design and compiler engineering efforts since about 2021.
Okay, my name is Jenny, and I'm the co-founder of Blockcast, which is a blockchain and crypto media from 2017. And I used to work for exchanges like OKX and Bybit. I also worked in projects and token funds. So basically every sector of this industry. Okay, let's start with our first topic. What is the most critical bottleneck for scaling Ethereum today? Is it the cost of data availability, the efficiency of the execution environment, or the fragmentation caused by the multi-layer tools?
Yeah, so like I mentioned before, back in 2017, so Ethereum is trying to using the sharding technology to scale for the TPS, transaction per second. Ever since that, so scalability is always the #1 issue for the Ethereum. And then when we're moving from the sharding technology into the module ones, basically we have layer 1, layer 2, DA layer, and settlement layer. And how we do that is instead of only focusing on like the layer 1, so we have layer 2, which is help us to do like more transaction per second, right? So that's why we have Arbitrum OP and there are like over tons of like layer 2s. But so far still there are some main issues we haven't solved yet. The first one is even the L2 maybe have higher TPS, still L1 itself maybe like a bottleneck. So that's why for starting from later last year, so EF began to focus more on the scaling L1 itself instead of focusing on the scaling L2. And the second one is because we have the module ones, and within, if you want to withdraw some money from layer 2 to layer 1, it still takes much longer time, for example 7 days. Vitalik once said it's unacceptable. So basically we definitely want to use the same security level, but that shorten the time if we want to withdraw money from layer 2 to layer 1. And plus the last one is when we talk about scalability, it's not only about transaction per second, it's also about the on-chain space. Because if there is not enough on-chain space, basically all the other, like for example, AI models, we just cannot run everything fully on-chain. Yeah. So back to the question, I think so far the three pieces which are, I think it's also the focus for the EF right now. The first one is scaling L1 itself. And the second one is how to shorten the time if we want to withdraw money from the layer 2 to layer 1, if we want to maintain the same security level. And the third one is instead of only scale for the TPS, how can we scale for the on-chain space?
Thank you. Learned a lot. So when thinking how to answer this question, first I'm thinking what is the challenge or the issue, the problem, the project or Ethereum would like to solve in order to answer the question, what is the bottleneck? So then I need to think about from our perspective, our reality. And in Her2, what we are aiming to build is, or our true belief is, blockchain in general is redesign the incentive plan. And Her2, what we would like to do is to through AI training, data training, and we bring AI for science, bring AI, onboarding AI to Ethereum. Then it's a lot of data based. So then based on these facts or this foundation, then we think the biggest bottleneck for us is data availability cost and data availability, DA cost, and the incentive design. That will be from our answer.
Cool. Mesh, what's your view on this?
Yeah, I think Anthurine, you've really hit a lot of the core points, and these are some of the core challenges that we're also trying to solve. So for me, out of those three problems, the big ones that are relevant to us at Boundless are execution limits and fragmentation, not only across L2s but also L1s. I'll dive into that later in our panel. But how we're thinking about, or how the problem of Boundless kind of came about was we realized that blockchains were broken in the sense of how they were validating consensus and how they were validating execution. So right now, for most proof of stake like systems, you have your validator set, and each node basically has to re-execute the transaction to verify that it happened correctly. And so our goal is really to compress all of that execution into a very, very small ZK proof. So big compute, small proof. And this has a lot of positive consequences for developers and also users. So at the developer level, one of the key things that we're looking to do is basically allow for limitless execution, right, or infinite execution. For EVM developers specifically, we've built a EVM execution prover, which is alloy-based, so it's called Steel. And what it does is that it really allows you to go back and query back to all of Ethereum's historical state, query back as many transactions as you want, do as much complex calculation as you want off-chain, and then it compresses all of that into a small proof that's generated by the Boundless marketplace. And that basically means that you have a tiny proof that only takes 300K gas to verify. You can put in as much transactions as you can into it, you can put in as much execution as you can, and then you can still be an application that's verifiable and that's on-chain, even though you can leverage off-chain computation and execution. So that's been a great unlock for lots of developers that are building cross-chain lending protocols or rebalancing applications, rebalancing your assets across different networks. And then for the user, the biggest guarantees is the security piece that you mentioned, from the L2 to the L1 withdrawal. So by compressing a lot of, by verifying and then generating proofs of a lot of data on L2s, compressing that into ZKPs that can later on be verified on-chain, where you're also verifying this finality of the transaction. And what that brings down is the 7-day bridging window, right? So, or withdrawal window. For many chains who are leveraging Boundless for ZK fraud proofs, we're able to bring down the bridging window to around 3.5 days. This is if they only use the boundless protocol in optimistic mode, and they generate like a ZK proof whenever there's a challenge. And then if they plan to use the boundless protocol for validity proofs, you bring down the withdrawal window to 1 hour, which is a huge positive kind of improvement in enabling faster finality, faster withdrawals, but maintaining the same security guarantees that you want at the Ethereum level. So these two pieces are very important, not only for improving the transaction limits and the bottlenecks that we're facing there, but also when you can create these small proofs, you make them reusable and you make them really portable across all of these different networks, which means that one network can now verify a boundless proof on another network if it supports our verifier contract. And that's a key way in where we think that we're able to solve the fragmentation problem as well.
Charles?
Yeah, I just wanted to continue kind of off of what Anthurine said, which is that, scaling used to be, people used to be exploring sharding, and then that morphed into kind of this exploration of L2s, roll-ups as like a way to like scale Ethereum's overall TPS. But then kind of over time, it was revealed that that doesn't entirely work because the L2s have their own incentive models. So the L2s are all like competing for their own order flow because they're making money from sequencer fees, and they might not actually be kind of cooperative with actually growing Ethereum itself. They might not want to like share user headspace or order flow, or whatever you want to call it, with other L2s. And also what was noticed is that a lot of what's this so-called juicy flow, which is that, like for example, MEV, which is where Ethereum was making a lot of its transaction fees much earlier, 3 or 4 years ago. All this is based on like sequencer flow, right? And this revenue all ended up going to the L2s, and data availability is now considered like a very commodity thing to do. So I think in the last year or two, there's been a shift where people have started to look at the other chain called Solana and be like, how can we actually increase TPS on the base layer? And Solana actually demonstrated very by doing things just from an engineering perspective, delaying the state root, different account models. So I think that right now that there is a lot of juice in just scaling the ETH L1. For example, I think at the EF what they're kind of researching are these like parallel block building. So you have heavy builders, heavy block proposers, but the verifiers are relatively cheap because they're able to, in terms of an engineering challenge, they're able to get the state accesses in a way that they can parallelize verification of the transactions. And I think that the holy grail is of course sharding of the state, among different parallelization of the state really, because for a long time and still the main bottleneck to scaling the L1 is concern about state growth. So if you can kind of solve this problem about state growth, either through sharding or through encrypted data, so zero knowledge databases, I think those are the ways that are really being explored at the L1 level right now.
Cool. And just like Anthurine and Mesh, you guys mentioned about the security of the layer 1 is like really important. And what methods or like standards must be adopted to ensure the data is reliable across all chains? Like I know that you guys had mentioned a little bit about. Can you elaborate more on this point? What standard must be adopted to ensure data is reliable across all chains?
Yeah, I think that's primarily a question for any panelists that are kind of in the DA game. I think for us, our take is really that if we want to scale Ethereum and we want to help applications on Ethereum scale, we have to allow for the compute to scale alongside with it. So DA works really great with ZK because DA kind of allows you to, it ensures that data is available at the moment that you need it and that it can be verified. But you also need strong, abundant, live, verifiable compute guarantees to make sure that anyone can verify that data and can make sure that anyone can ensure that it was computed correctly. That's one of the ways in where you can ensure that the security guarantees have been maintained from the L1 to the L2. So when we were thinking about the boundless kind of marketplace or the proving protocol, a lot of our founders have, a strong degree in Amazon. And when we were looking at AWS and we were looking at, okay, Web2 applications and how they scale, we realized that as Web2 applications scale, the cost for EC2 scale as well, which is the compute part, not necessarily the storage part. And so when we were thinking about, okay, well, how do we build a permissionless, open, ZK marketplace, and how do we make sure that compute is reliable and available for as many teams as possible, we addressed it from this model. And so we built our marketplace with a core focus on making sure that the supply side is continuously live and it is good quality, reputable supply. So when you think about the boundless marketplace or the proving marketplace where you can get ZKPs for any rollups, L1s, or applications on any chain, the core piece that drives the marketplace is our provers. And the way that we source our provers is in a completely open, permissionless, and decentralized way. It's a very complex problem, really, because you have to extract a lot of the centralization-like aspects and make sure that it stays reliable as more provers join. It's also complex in the sense of the incentive mechanisms that we have to keep provers live. So what we have is an incentive mechanism that's very similar to Bitcoin. We call it ZK mining or proof of verifiable work. The thing with Boundless is since we've inherited a lot of RISC-0's technology, we can actually quantify the amount of compute that a prover does or a GPU does, which means the amount of cycles that a prover completes. And then the prover is able to basically claim token rewards proportional to the amount of work that they do. So that's very key because we're not just giving proving free for all, and most importantly, provers also have to have some skin in the game. They have to stake some of the token to make sure that they're eligible to claim as well. So that's a very key piece in how we're making sure that the supply of compute is consistently there. That anytime a rollup wants to go and they want to generate like a fraud proof, they can. They don't have to worry about it not returning. Or anytime an application wants to go and generate ZKPs and generate the ZKPs with the trust guarantees and the trust assumptions of the L1, they can do so. So compute is probably the biggest way that we're trying to solve, kind of scaling and making sure that ZK is accessible to folks as anytime that they need it.
And I also got a question, especially for Anthurine. Anthurine. How crucial is the continued evolution of decentralized storage solutions to long-term scalability of Web3? Since you guys are doing the Ethereum storage.
So since you just mentioned for DA, right? So the DA is definitely perfect. No matter it's Ethereum DA, Eigen DA, or Celestia. So they're all doing different ways of DA. But one issue for all of them is they're not going to maintain the data on the DA layer forever. Basically, the data store for the DA layer compared with before the 4844 is much bigger. So this is actually the first time Ethereum threw away data after certain days. For example, for Eigen DA it's about 7 days, and the Celestia is a couple months, and for the Ethereum DA, if I remember correctly, it's about 14 to 21 days. So after that, that means you cannot find all the data, historical data. So how we position ourselves is we're actually working with all the DA solution to help them store data forever, because that's a rule for the blockchain. All the data is traceable. So you will find all the history, transactions, whatever. So that's pretty much very important. And the second one is why do we care about the on-chain storage, decentralized storage? Once Vitalik was asked, how do you think the Ethereum will be? Is it a DeFi kind of financial tools, or so his answer is he hopes the Ethereum can be a world computer. Just now in the keynotes, the previous CEO also mentioned that. So basically, for the world computer, instead of only having DeFi apps, you would like to see the versatile apps for example, like very popular AI, decentralized AI models, like decentralized social network, and all the other kind of stuff. And we know, except for the DeFi applications, all the other DApp, they do require a bunch of on-chain storage. And if there is no on-chain storage, you have to do everything off-chain. For example, when we talk about Web3 AI, what we do is we actually run the model offline. We have no idea what the process will be. When we have like a readout, we don't know we rewrite it or not. We just put that readout into the on-chain, and that's it. And we call it so-called like Web3 AI. But everything should happen on-chain. So that's why it definitely requires a bunch of like on-chain storage. So currently we can help the L1 to increase by 1,000 times and L2 increase by 10,000 times compared with the on-chain transaction, and also lower the fee by 1,000 times. And the on-chain capacity right now can reach PB level. So that is pretty much enough to cover some small to medium model. And I'm sure for the super big model, it doesn't that necessary. We have to put that on chain, right? For example, like the ChatGPT, whatever. So that's why we feel like the decentralized storage is essential if we really want to achieve the goal of world computer.
And the next question is for Lin. As the ecosystem fragments across layer 2s and rollups, what infrastructure or protocol solutions are most essential to achieve a united, seamless user experience, like of cross-chain interactions?
So actually, this question I have discussed with our Professor Tianlin. Users should not be bothered to or even not necessarily know about the which rollup they are in. So the path there is like shared security and maybe settlement standards plus intelligent routing middleware that abstract the complexity. So think of the internet routing, for example. Users don't care which server package travel through. They just want reliability. So in He2, what we experiment is like with subnets. So on the main chain, and we onboarding more than 100. We are capable of onboarding more than 100 subnets. So with this subnet architecture, they can be complete but settle back to common hub. And by doing this, I think Ethereum will see similar dynamics play out across the rollups.
And Charles, and the final question is for you. Like looking forward, what infrastructures or tool breakthrough do you believe will be the single most transformative for adoption and application performance, like for the next 1 year and a half?
Speaking as a language designer, I definitely think that there's something to be said for developers and developer ergonomics. So how they use the language, primitives that are in the language that can help them reason about cross-chain transactions, other tooling that helps them test across chains, and so on and so forth. From a non-tooling perspective, I think that any breakthroughs in state parallelization will be extremely crucial for scaling of blockchains in general, and especially Ethereum. And I think that is definitely the most important thing for researchers to be working on at the moment.
Cool. And before we wrap up, and I really learned a lot from each panelist. I want you guys to share a little bit of what do you see in the future of Ethereum scaling? What are the solutions and what are the futures you guys are planning for your own projects?
Yeah, sure. Like I mentioned before, so for us, we feel like there are three crucial problems need to solve for Ethereum scaling. The first one is scaling L1. So right now we have done a bunch of work to improve the parallel EVMs. For example, like the block level access list, which will give like a better like parallel I/O. And also, so we have done a bunch of experiments to improve the G Ethereum, scalability. And the second one I just mentioned is how to shorten the withdraw time from L2 to L1 with the same security level. So risk zero already have like a one solution. So actually we are one of the other team helping OP doing like another fraud proof, helping them to shorten the time by 70 to 90%. And the third one is, except for the TPS itself, we would like to scaling more for the on-chain storage, decentralized storage. So in that way, we will see more the app pump up instead of just a DeFi.
Scaling Ethereum probably is not just about the increasing the TPS and the finality. So when in working with Her2 protocol, we think we need to put down to practical. For example, we can unlock those categories, like more categories. For example, AI. For example, science. For example, more monetization in different other in other world. For example, in the real world. So that is more challenge. The next step in the future for the next 1 to 3 years. So I believe the next circle won't be what we are seeing now. I hope it will be real-world computational adoption or even application in this field. Yeah, thank you.
Thank you. And Mesh?
I don't know if folks remember this quote from the Hackers movie. It was by Angelina Jolie when she said like RISC-V architecture is gonna change the world. And it did, right? And now it's going to change crypto, I think. We're seeing, RISC-V not only change the standard for how ZK is expanding and evolving, but also how Ethereum is expanding and evolving, and specifically with the L1 certification kind of progress that they're doing. But also what RISC-V really allows us to do is, for Boundless specifically, it has allowed us to really build all of the tooling that has really helped us scale, like EVM execution, but also expand this to L2s, right? So similar to Quark Chain, we are also part of the OP stack in terms of supporting OP's dispute games. And so one of our product offerings really helps a lot of OP stack rollups and L2s in general prove their network and reduce their withdrawal windows. And what it really does is also help them kind of expand beyond where they are and beyond Ethereum itself. So as we kind of rolled out our work in ZK Interop, the first step was proving L2s. The next step is now proving L1s and specifically alt L1s. We've already done the hard work. A couple months ago at mainnet beta, when we launched mainnet beta, the biggest kind of thing that we launched was the Signal, which was a ZK Ethereum consensus client. What this means is we've compressed lots of expensive Ethereum data, including consensus and finality, into one small proof, which can be basically readable and portable to any network that we support. And now we're going to do this to Solana, Bitcoin, and as many L1s as possible. We already have, work with Stellar and XRPL along the way, and we're creating this foundational kind of trust layer where ZKPs or ZK verified state can now be read across layer 2s and layer 1s. And what it creates is this unified developer interface for the next generation of builders and applications to really build with scale in mind and to not feel like they're constrained. So our goal is essentially at the builder level to help builders in the long run deploy once and be everywhere, and then for users to accept deposits, withdrawals on any network, from any network, in one single click. So that's the future that I'm hoping to contribute to.
That is pretty cool. And tell us, what's your future plan for Viper?
Oh, well, I was actually not gonna, since I'm the last one, wasn't gonna talk about any specific technology, but I want to paint a vision for the future. For example, building off what Anthurine said, she was saying that maybe not ChatGPT run on the world computer, but why not? like, I think that a world computer should be able to run these huge programs, internet search, AI, all kinds of things. And that's the kind of thing that is unlocked as the technology actually scales. And I think there are, as Tianlin was saying, there's not just compute scaling, there's also developer scaling, there's DevX. As DevX improves, we'll see more apps being built and more easily. As security, which is a big focus for us at Viper, as security improves, as contracts got easier to audit and verify, then we'll see an explosion, really, even more so than today, of apps and software that are being built on the world computer. And I think that's going to really increase the diversity of things that people are able to use. And from a UX perspective, as the UX improves, past just MetaMask, past these kind of wallets of the past, as UX improves, we're going to see a great onboarding of users. And so it'll be much more integrated into our daily life as more UX patterns are discovered. And as assets, actual real world assets such as stablecoins are scaled, then it's also going to permeate our lives in a more general way. So, and for real world assets to scale, you need legal frameworks, you need better technology, you need more connectors. And so these things are all kind of synergistic aspects of the same thing, which will increase the reach of Ethereum and kind of get us to the decentralized future that we're looking for.
Thank you for your sharing and insights. And is there anyone who wants to pose a question to our panelists? If not, we're gonna wrap up. And thank you so much.